Hello YouTube. Today we're going to work on pretty much converting differential equations in matrix forms. So you're going to be given a differential equation which has two variables or more, and we're going to convert it into a matrix form. So we're just going to jump straight into examples. This is mostly going to be an example type video for practice problems. Okay, so we're given this set here. These two represent slopes in different directions, and later you'll see that it's more like a direction field, a vector field, so every point has a slope, and this will help you calculate what the slope is, but right now we're just going to convert into matrix form. So to do that, you're simply going to utilize the coefficients here and use this form. So this is the form you're going to be using to solve or to convert from differential equations into matrix form. So remember, this pretty much represents two equations, like you can see them in that direction. So just keep that in mind when you're evaluating these or converting these, that this is multiple equations, multiple variables. Okay, so let's go back to this problem here. So we'll start by utilizing the coefficients. So you're going to pull them out, and the order is going to be x1, x2, and x1, x2. So we're going to do that. So our x1, just going to pull out the coefficient, is 2, and then 3. Then for the next one we have -4 and 1, right? So use that here. And then this is for x1, and this is for x2. And that is pretty much the converting this into matrix form. That's the first problem, so let's just do the next one. Same thing, utilize the coefficients here. So we're going to have 1, 1, 1, and 1, and then this one be plus 0, x1, right? But since we're doing x1 first and then x2, you've got to make sure you keep it in the same order and be consistent. So this would be 0, and this would be -2. Same thing, and you add x1, x2, and that is your slope of x. There you go. Next problem, same thing, be careful of the subscripts there. So this would be plus 0x2, and this would be plus, oh wait, I think I'm missing another thing here. Hold on, this would be plus 0x2 and plus 0x3. We need to have an x3, don't we? Okay, so I forgot to add the x3, so now there is one. So we're going to utilize the coefficients here. So this would be 1, -2, 0, 0, come on, 0, -1, 0, and 0, and this is 1, 1, 1. So now to convert it into matrix form, just do x1, x2, x3. So for the first one, we have our first coefficient is 1, our second coefficient is -2, our third coefficient is 0. Then we have -1, 0, and 0 from up here. And then finally we have 1, 1, 1. And then we simply add to show what they represent here, x1, x2, and x3. And that is converting to our matrix form, dx dt. Okay, just an overview, recap of what we did. So we organized by x1, x2, and x3. We determined the dimension, so I didn't really talk about that here much, but notice how there's 3 dimensions here. Actually, this is a 4th dimensional device here. And then we have, just so you know, like how many to put for your matrix. And then we utilize the coefficients, obviously. We did that. And then finally, oh, let's do this. We'll add a little thing at the end. So let's calculate the trace and the determinant. And to calculate the trace is using, you simply add the main diagonal for the matrix, and then to find the determinant you do a times d minus b times c. So why don't we do that for at least the first two. Okay, So I'll write that in red. So the trace, remember, is the sum of the diagonals here, so this plus this. So 2 plus 1 equals 3. And the determinant would be 3, let's do, what was it, A, B, well, I forgot again, hold on, AD, that's what it was, AD minus BC. So 2 times 1 is 2, minus 4 times negative 4 times negative 3 would be plus 12, so the determinant is 14. Okay, let's do it again. Trace. Simply add these two numbers together and you get negative 1. 1 plus negative 2 is negative 1. The determinant would be, just to show my work, it's 1 times negative 2 minus 0 times 1, vice versa. So you would have negative 2 as your answer. So that should be enough practice for now. So yeah, there you go. So that was the main formula we used, remember, and here's a recap of what we just did in the video. So good luck and keep practicing.